Hi everyone, Mr. Higgins. Just going to show you a little bit about polymers, specifically addition polymers, which is all you'll need to know for AS level chemistry. You will come on to something called condensation polymers, but that won't be until year 13. So starting off, addition polymers. You need to know what the word polymer means, and to begin with, poly comes from a word meaning many, and mer comes from part. So therefore polymer means something made of many parts. And effectively what a polymer is you have lots and lots of small molecules, these are the different parts, that join together to form a chain. So if you can imagine you had lots and lots of small molecules added together, join these all up, and you end up with a chain molecule. So these are what's called monomers, and again same, mono meaning one, so monomer, one part, and a polymer is once those parts have joined together. Okay, now specifically monomers, in the case for addition polymerization, monomers are always alkenes, because alkenes have a double bond which can be opened up and therefore allow extra carbon atoms to join together. So let's say we started with this molecule, which is, as you can see, ethene. Alright, what happens is the carbon-carbon double bond is going to break open, and you're just going to have a single bond between those two carbons. The remaining electrons that were in that double bond are going to move to the other sides of the carbon, so you're going to get a bond on either side of those carbon atoms. Okay, the molecule is going to straighten itself up, and you're going to effectively get a repeating unit. So if I was going to draw the polymer formed from this monomer, it would look like this. Straighten up my molecule, I want all these bonds to be vertical instead of on an angle. So all those bonds become vertical, and here I've got a double bond, but I don't want a double bond in a polymer, I want it a single bond, so I'm just going to turn that into a single covalent bond. I have large bonds coming out either side, and then I put big brackets around it and the number n. Alright, now that n just stands for number. So let's say the number is 50, that means I'm going to have 50 ethene molecules to begin with, and I'll have 50 repeating units of this section in a chain. So those brackets in there is what's called a repeating unit. It basically means that I will have this section repeated n number of times in a chain. So if n is 4, I'll just have this 4 times over, so I'll have 8 carbons in my chain. But if n is 12,000, I'll have 12,000 of this unit repeated in a chain. So what I'll do is I'm going to write down a simplified version of the rules you need to make to go from a monomer to a polymer. Number 1, straighten up. Okay, we don't like having bonds on angles when we're making polymers. It's helpful for alkenes because it allows you to work out things like EZ and cis-trans isomerism, but when we're making them into a polymer, we want those bonds to be vertical. Number 2, single bond. Alright, the double bond from your alkene breaks, and you only have a single bond between those two carbon atoms. Number 3, big bonds. Okay, so you want large, long covalent bonds coming out of either side of those carbon atoms. Number 4, brackets. You put a bracket around the entire structure to show that that is one repeating unit. So that structure, the whole thing inside those brackets, is repeated over and over again. And number 5, just put a little n outside the brackets to show how many times that repeating unit is done. So what I'm going to do is I'm going to draw for you a few monomers. I'll draw 4, and once I've drawn the 4 monomers, I want you to pause the video and I want you to attempt, in fact I'll do 2. I'll do 2 monomers and I want you to pause the video and attempt to draw the two polymers formed by it. So first of all, go for that one, and secondly, go for that one. So pause the video now and have a go at trying to, sorry it's not quite getting particularly focused there. You should just be able to read it. That is a CH3 group, the rest of my hydrogens, and here we've got 2 fluorines and the rest of my hydrogens. So pause the video here, have a go at drawing the polymers for me. Okay, so what you should have had, if you've drawn them properly, is you're going to have, remember, straighten up your molecule. So all those bonds are going to be vertical. We're going to have a hydrogen, a hydrogen, a hydrogen, and a CH3 group, a methyl group. Single bond between those 2 carbons. Big bonds on either side, brackets, and an N. Okay? And then same down here. So straighten it up first of all. The whole molecule wants to be straightened up vertically. Single bond between your 2 carbon atoms, so you can't quite see that, there you go. Big bonds either side, brackets around it, and an N outside your brackets. Okay, if you got that, well done. Okay, last little bit is I'm going to give you some slightly more complex looking molecules, for example some skeletal formulas, and I want you to try and polymerize those. So what is a polymer for that going to look like? And what is the polymer for that going to look like? I'll see if I can just refocus that. There you go. Can you draw me the polymer formed by both of those? So pause the video now, have a go, and then I'll go through the answers. Okay, so this here is my carbon-carbon double bond. Coming off of it here, I've got a methyl group and nothing else, or from what you can see, nothing else, but it's a skeletal formula. This carbon must be making 4 bonds, so it's got a double bond to the other carbon, it's got a bond to the C from my CH3 group, and therefore there must be another hydrogen. So in your polymer, you're going to have your CH3 group up there and a hydrogen. Over here I've got 2 methyl groups. Single bond between them, big bonds either side, your brackets, and an N. That is the polymer version of this. Okay. Next, here, there's my double bond. So on the left hand side of it, I've got an ethyl group and a hydrogen. So my hydrogen is above the plane of the double bond, my ethyl group is below it, so I'll just put H5C2 to show an ethyl group. Sorry again, can't quite see that, there you are. The other carbon, I've got a methyl group, and then I've got a benzene ring attached. So carbon, CH3 up there, and below the plane of the bond, I've got a benzene ring. You can just draw it like that, or you can put C6H6, or C6H5, sorry. Big bonds out either side, brackets around it, and an N. Yeah, okay, good stuff. Thanks guys.